Alrighty. Well, it's 11 a.m. I think time to get started. We've got people coming in. I'll try and keep on top of that, but really quick, I wanted to, right at the top, just have a quick announcement from the SORA Executive Committee. We're looking for new general members. So anybody who is a member of SORA is bunch of people coming in. Yeah, anybody who is a member of SORA is welcome to come and join the executive committee. We meet once a month for just like pretty much an hour every time. We have those meetings to plan webinar and learning events like this one to discuss development opportunities for our membership and passing those types of opportunities along. And as a general member, you can join all of the discussions, vote. You have all of the privileges of any of the named positions, like myself being the chair of SORA. We have a vice chair, communications coordinator, all that good stuff. But yeah, joining as a general member is a good way to kind of see if that one of those opportunities might be for you. A good way to kind of pitch new ideas for any events that you want to see happen. Make sure that your voice is heard in the planning process of all this stuff. So yeah, contact me, Michael Mativa, michael.mativa@dor.oregon.gov if you're interested in joining as a general member. Our next meeting, I believe, is maybe next Tuesday. It is indeed next Tuesday, 11 a.m. So yeah, if you can make that, feel free to shoot me an email. We'd love to have some new people in. And then we've got elections for the named positions coming up in January. So again, like I said, joining as a general member, a good way to kind of get some experience, just see how the executive committee operates, if you might be interested in running for any of the named positions. Gives you a couple months to get some experience with it. And yeah, so with that announcement out of the way, and again, just shoot me an email. Contact information is on the screen, michael.mativa@dor.oregon.gov. Just shoot me an email if you're interested. So yeah, with that out of the way, we have, I can stop sharing. There we go. We've got Jeremy Allen up first as our first presenter. This is going to be about the first half of our hour here, and then we'll have a couple of show and tell cases for the back half. But Jeremy is coming to us from Posit, the company behind our studio, an IDE that I use just about every day. So yeah, he'll be talking to us about just kind of the basics of R for people that aren't quite as well versed, how our studio kind of comes in, and yeah, some of the common packages I think that people use for data analysis and data wrangling, all that good stuff. So without further ado, I will hand it off. Jeremy, take it away.
Thank you, Michael. Appreciate the invite. Really good to be here. And one thing I would like to do for everyone that's listening, if you don't mind, into the chat, type how many years you've been using R. So just type the letter R and then the number of years. If you're a Python programmer, you can type a P and then type number of years you've been using that language, or however you want to do it. But I'm looking at the chat, and what I'm looking for is I'm seeing all these numbers go by. Cool. Get a sense of experience from everyone. Awesome. I see zeros. That's what I like to see. I like to see people that have not done any of this before. So this will be all very new to you who have 0 years. And I got to tell you, I wish I was in your position when I started, because you're starting the right way by being in this group. All right, I see some going up to 10. Let's see, who do I have over 10? I see 10 plus. Okay, excellent. but we don't know how much that plus is. Is that like 20? Or is it like 11? I don't know. Maybe we'll find out. Yeah, lots of ones, twos, threes, a little bit of 7, a 6, 8, 10 plus. That's a good range. We got a null value. Nice inside joke. SAS 10, R less than 1. Awesome. Well, let's get into it. I'm going to share my screen and share with you a little bit about Posit, who we are, but also R, the programming language, how it came about a little bit. I think the most exciting thing we're going to talk about is what people are doing with R today. I'll mention a little bit about Python too, since some of you have some Python experience, but I think most of this will be around R. Right now, I'm getting my chat window repositioned, so I keep an eye on the chat. And I know we're going to stop at the bottom of the hour. It's 2 p.m. for me, so it'll be 2:30 when I aim to quit. I'm going to stop before that, so we have Q&A time, but I'll just try to make sure we are able to wrap everything up by the bottom of the hour. All right, so I'm Jeremy Allen. I am a sales rep at Posit. I started off as a customer success rep at Posit about 3.5 years ago. I came from government service. I was in the Army for a long time. I was a defense contractor for a long time, researching terrorism. That's how I learned R. That got to be a pretty disturbing job. Didn't want to do that for the rest of my life. So Posit and R Studio and our programming language and Python, all of these things are much more pleasant to work with on a daily basis than analyzing terrorism propaganda. So here I am, having a much better time. And I'm happy to be able to share it with you. So R is a programming language that we do not make. We are Posit, used to be called R Studio because we make the R Studio IDE, but we also support Python and now Julia and some other languages. And so it makes more sense for us to have a name that doesn't have the name of our IDE in our company name. So we're Posit, but for people that are brand new, we don't make the R programming language. That's controlled by other people. And I do want to give a really brief little tidbit on that history. So what we're looking at here is a book actually written in the R programming language and published online. But I just want to look at this particular quote. This is actually from the S language that preceded R. And it's a quote from John Chambers. He says, "We wanted users to be able to begin in an interactive environment." Think the R Studio IDE is probably what you've experienced now, but back then they didn't have that. But his idea was people would start in this interactive environment where you don't have to think of yourself as a programmer. And then the more you use the language and become comfortable as a user, you can gradually move into making things for the language and making more complex things. And what most people would consider at that point a programmer. But this language S came about, I think, the year I was born, 1976. So, you do the math, you're researchers, I'm over 40. But R came later, much later. You can see down here, 1991. So it hasn't been around nearly as long. And you see started in University of Auckland in New Zealand. So R has come a long way since then. I'm in a position where I'm fortunate enough to interact with a ton of people who use R and have been using R for a very long time. So some of what we're going to talk about here in a minute are some amazing things people are doing with R, because I want you to get a sense of what's possible. And it's one of the most eye-opening parts of my job. I originally thought of R as just a statistical language. People do statistics. But wow, that's an understatement. They do a whole lot more. And I want to talk about that. I'm going to just glance at the chat too, just to make sure there's nothing coming up in the chat that I need to stop and address. Okay, Kara knows the book and she likes it. It's by Roger Ping. He has a podcast too. So let's go back to the title. Here's the book, Our Programming for Data Science. But if you search, you'll be able to find Roger's podcast too. If somebody knows it, you can write it in the chat. So we want to look a little bit at the history, how it's been, what have we done? In our case, it's been a lot. I talked a little about history of R. What you're going to see here is a little history of RStudio, the company, and Posit. We started way back in 2009 as a company, and then we produced the open source IDE in 2011. And since then, it's just been sort of a wild ride, making open source packages, making other products in addition to the IDE, like server versions of the IDE, commercial products. We work with a lot of government agencies and companies who are in environments where they just need enterprise features, enterprise grade features like authentication and security. And while they love using the open source versions, there's just environments where they have to have professional tools. So they asked us to make that stuff. So we started making that stuff. So we make commercial and open source versions of just about most of the things that you see. And I imagine you recognize a lot of the R packages here for those of you that have been doing it, but let me highlight a few that are particularly important. In 2012, the Shiny package. You may not know it's that old, but yeah, it's that old. It's been around for a long time. Shiny is an application framework for the R programming language. If you want to make an application and you know R, you can use Shiny and you can make a web application. R Markdown is from the same year, also 2012. And that's for reports. If you want to mix text and code and output all in a document and make a fantastic report and do it all with code so it's reproducible, so you can automate it, so you can collaborate with others, R Markdown was really great for that. And then along the way, we started putting more time and effort into the commercial products. That's how we fund our company. That's how we pay our salaries. And that's how we keep paying the open source developers to keep making the open source and free things. So we have to keep the commercial business going alongside the open source business. But we make great commercial products. I'm going to talk about those some, not from the point of view of me being in sales. So pardon me if any of this sounds like a sales pitch. It really is not. I'm just trying to convey to you sort of the scope or a broader view of the landscape of the R programming language and how Posit fits into that. And just by the nature of our mission to produce a public good through our open source products, we also make commercial products. So that's part of the discussion. So what are people doing with all of this today? I'm going to start small and we're going to work up to some complex examples. This is super simple. In the bottom code chunk, it's 2 lines of code importing a table of data about WNBA. It's the Women's Basketball League. It's just a table of data about some team stats from back in 2004 that gets piped right into a function that converts that table into an HTML-based table that's interactive. So with just those bottom 2 lines of code, you get something like this. I call it the easiest table. This is an HTML table. It's hosted on a web server so that you can interact with this table by sorting columns. You can filter these columns by typing in these column headers. So just like that, pretty simple code. You can take something like an Excel spreadsheet or some other flat file data, turn it into an HTML report, as long as you have a place to host it. And once you do that, you can automate that kind of thing. You can do it for more and more people, for more and more data sets. And then all of a sudden you're able to share links with people. People can access that data just through the link. If you're the one updating it, they don't have to worry about versions of the flat files. They just know, I go to this link, Jeremy will have already updated that data because he does it every night or every Monday or whatever the case is. And really what I want to communicate here is don't overestimate what it takes to be useful. You can be a hero to people by automating very simple things. If someone has a table or a graph or a couple of slides they need to develop every week for their bosses, and you know R, Python, and you can automate some of that work for them, you'll be a hero. You'll be doing great things because you'll be freeing them up to do other things. And it's really those other things that you want to think about being possible and not missing out on. And if we go up a little bit in complexity, this is not the complete code. I just snapshotted the top bit of the code, but I'm introducing a little bit more complexity here. I have a script that scrapes our professional product release notes from our website. I don't particularly like our release notes website. I think it's harder to read. So I have a script that's scheduled to run every night. It scrapes all the text from our release notes pages, puts it into a dashboard in a way that I like to read it, and it's searchable in a way that I like to search. So I've introduced a little bit of dependency to my project. I have to have access to the web. I have to go out and scrape the data. But in this particular case, this script just writes the data to another location. It's not producing a report. This script is just going to get it, cleaning it up, and then putting it in a place where another script can use it. And we're going to go up a little bit more. In this case, sometimes at my job, I need to think about currency exchange. If I'm selling software to another government and there's resellers in between, some of those folks have questions around the way the prices are going to come out if the currency is converted at different times. And I wasn't really happy with the available currency conversion apps, so I just used Shiny to make my own, and I host it here on one of our servers. And so now I can use this. But, you know, it's a level up in complexity. Now I'm relying on an API from another service. So there's another company who provides currency exchange data. They make it available on the internet through their API. So I have to pay them a fee. I have to have an API key. My code has to store that API key in a secure way. And then I have to hook all that up to the back end of this Shiny application so that the Shiny application will work in a secure way and give me what I want. But it gets more complex. This is an example from your own state. This is some Oregon injury data. Andy, I think I saw you join. This is one you sent me. So I'm going to reload this. Andy, who's part of the group here, Andy Nunez Brewster. I don't know if it was him or just his group or his organization, but they put together a lot of data analysis and make it public through these dashboards. And since they're public, I'm able to see them. But it's a little more complex. It's not a single page application like my currency converter. You can see we got multiple pages on the left. We have some state trends. There's some user input that can happen, deaths, hospitals. I can even filter by injuries. And it looks like to me people being poisoned. So you're going to have to get on that. Data descriptions. So there's a lot of metadata type things here other than just the front end, you know, the sexy part of the application itself. So it's very well rounded. There's a lot going on here. So if you needed to come and understand this data, there's a lot here that can help you do that. Ah, Ariane says, it was me. Excellent. So now we know who actually made it. Andy shared it with me, but you made it. Awesome. Now I know. And let's go up one more level in complexity. This is a multi-page Shiny application by California's Department of Health. They have this hosted on multiple Connect servers. Connect is a product we make. It's one of the commercial products to host Shiny applications and reports and APIs, kind of all the things you need for a web app. And they know that this is a public application that's going to get a lot of traffic. So they needed to put a couple of servers together in order to load balance high traffic in order to host this application. And it's very nice. data on COVID-19, on influenza, multiple tabs, multiple pages within here. You can download these data sets if this is a particular model that you like. The models are interactive. Lots happening here. And this gets a lot of traffic. So they had to put a lot of work. They had to do a lot with their IT organization, and not just the analysts who are producing the data. Those two teams, the data scientists and the IT folks, have to come together to make something like this possible. Now, I can't show you everything. It would take forever, but I was going to highlight some really cool things. I was talking to the Department of Agriculture yesterday, and they have a very complicated architecture in order to approve funding for landowners who are trying to conserve land and water that they own. Well, in order to do that, researchers from the Department of Agriculture have to go out and visit the land, sample the soil, sample the water, test for certain things. If everything is meeting the right conditions, funding is approved. That all comes from Congress to the Farm Bill, through the Department of Agriculture to the landowner, and now they're implementing something on the ground that is improving or helping to resist some of the more dangerous aspects of climate change. And they're doing it with R. And this is true across most agencies. Think air quality in the EPA, National Oceanic and Atmospheric Agency, also studying climate, effects of temperature on salmon, other things with marine life. Census studying us, how our population is changing. Bureau of Labor Statistics studying unemployment rates, other labor stats that are very, very important. If any of that data leaks or is incorrect, international consequences, economic consequences. Anti-fraud enforcement from other agencies who are keeping other large tech companies in check. A lot is happening around all of us. And if you dig deep enough, you're going to find someone who's using R or Python to create the data that sets all of these things in motion. And it starts on the left side of this graph, where people are conducting research and analysis. You're importing data, cleaning it, visualizing it, communicating it. But on the right are the IT folks that we interact with. And they're doing things like testing and continuous integration and authentication and access control and package management. From my experience in government institutions, sometimes these two cultures are far apart. Sometimes the academics and the researchers on the left don't understand the requirements of the IT folks on the right, and vice versa. The IT folks, they have their strict architecture requirements, and they don't understand why the researchers on the left need to move fast, need to share results without a lot of delay, without a lot of interference. But on the left, in research, your goal is to create new knowledge, understand how the world works. And to do that, you need to iterate and you need to move fast, and failing is okay, because that's how we learn more about how the world works. We call it science. On the right, the sharing and the speed and the simplicity are not the top priorities. The security, the control, and the stability are. I show this to a lot of my customers that I work with in hopes of helping them understand each other. The more you do with R and Python, the more complex it becomes. Each of these groups need to be thinking about the viewpoint of the other groups and not to think of them as enemies. But the sooner each side understands the other, the faster they'll be able to go. I see we only have about 6 minutes left to the bottom of the hour. So I'm going to stop for questions, but I do want to just say there are a list of resources here. I may have added some of these, Michael, after I sent you this PDF, So I'll resend this so that you have the latest version, but I want to make sure you know these resources are here. If you're curious about how to get onto this path and start with the simple things and be the simple hero and then build all the way up to these complex things, these right here are really good places to start. So I'm going to stop and we have 5 minutes for questions.
Great. Well, thank you very much. This is the just Teams webinar format. I think people dropping any questions in chat is probably going to be the easiest. So yeah, if you have any questions for Jeremy, any
questions
about kind of the Posit, the basics of R, maybe about any of these resources, if anything catches your eye.
I'll highlight a couple just while we wait on some questions to drop into the chat. The Big Book of R, this is not a resource from us, but the Big Book of R is a book someone else has made, and it lists all the other books about R. So it itself is not the Book of R, but it's a list of all the other books. So it's a great place to start. But some that we have made are R for Data Science, Advanced R, R Packages, and Mastering Shiny. All right, now I see some questions. Is there a capacity to use R for qualitative data analysis? Yes, that's how I got into R. I got into R through text analysis. One book for that would be Tidy Text Analysis by Julia Silge and David Robinson. A good package is their package, Tidy Text. But there's another one, Quant EDA, Quant EDA, Quant EDA. It's a very robust kind of set of packages, all for qualitative data analysis. Andy says he wishes his IT folks could learn from this so they understand, why we want to do programming and use version control. Yeah, and they can. It just takes a little bit of work. I think you'll be able to help them along. R or Python better for Shiny apps? Both these days. We released Shiny for Python maybe a year and a half ago. It's come a long ways. It's written from the ground up in Python. So it's not just a port of the R Shiny framework. So I would say either one. And we have, let's see, curious about deploying R Shiny applications for internal use over a local network. Yeah, you can do it. There's lots of ways to deploy a Shiny app. You can host it yourself if you know how to run a web hosting server, or put it in a Docker container and put it in a cloud-based service. We have tools. The free tool is Shiny Server, open source. That'll let you host a Shiny app on your local network as long as you can install it on a Linux server. Install the Shiny server on a Linux server. Or the more commercial tool, Posit Connect, that'll do that for you. Yeah, I think, Andy, you can drop those links in the chat for folks. Excellent. Yeah, AI, it's a question for Matthew. It's already impacting what we do. For example, the creator of Shiny is Joe Chang. He's also our Chief Technology Officer. He's already working on integrations of AI into Shiny. At our conference a couple of months ago, he demonstrated an integration of AI into Shiny in a couple of ways. One way it's integrated is taking your plain English requests for transforming the data, and the AI translates that to SQL in a very reliable way, queries the data, returns the data to the app. So in this case, the AI is just focused on generating the SQL to return the data to update the visualizations in the app. And it's very accurate. There's not hallucinations and all of that. It's very refined. Another way it's integrated into Shiny, or is becoming integrated in Shiny, is creating the application itself. If you need the AI to help you with the UI, the user interface of your app. That was also demonstrated at our conference. Those videos will be available probably within a month online. So just stay in touch with us, and we'll probably publish a blog post saying all the videos from conference are now available online. And so look for the one from Joe Chang and Winston Chang. And they talk in much more detail about AI. And I think that's all the questions, and we're at the bottom of the hour. So that might be a good place to stop. So thank you all.
Perfect.
I really appreciate it.
Yeah, thank you again.
Yeah,
Appreciate
absolutely.
you taking the time coming to speak with us.
Anytime.
But yeah, 2:30, we will keep it rolling. Next up, we have Ariane Erickson, who's here from OHA, giving us a little insight into, I believe, Quarto and some automated reporting basics. So yeah, take it away. Thanks.
Perfect. Thank you. Let me see if I can get this to share. Awesome. Can you see my screen? Perfect. Okay. It's a little clunky on my end, so I don't have access to the chat. I can only text through my phone, so sorry if I'm slow on that. Okay, so hello, my name is Ariane. I'm excited to be here today and honestly piggyback on some of the things that Jeremy was discussing. So today my goal is to try to convince you to automate your reports using Quarto. If you're in the data analysis field, you know that reporting is a really crucial component of data analysis, but it can also be really time consuming, prone to errors, and you can have some difficulties with consistency report to report. So if you're looking to streamline this process and you want to get your report out faster with less errors, you should try automating your report with Quarto and R. A little bit of background about me. I work at the Oregon Health Authority in the Prescription Drug Monitoring Program, or the PDMP. At a very, very simplified level, the PDMP is just a database that collects prescription information from both pharmacies and healthcare providers. And my role on the team is to report out this information quarterly. So what does the quarterly report process look like? In general, this means that every quarter I use a series of R and SAS cleaning scripts to generate my raw data. And previously, I used to manually assemble the report in Publisher, which would mean copying and pasting my raw data into Publisher and then formatting the tables from there. I would then kick the report from Publisher into Word, do edits within the team, and then finally, we would publish these finalized quarterly reports once everybody was in agreement. So in general, this process took about 3 to 4 hours to copy all the data from my raw data into my report. So no good there. I was copying and pasting and I would make errors. There were 6 different tables. Sometimes I wouldn't copy certain values over. And so that process was not working as well. And then on top of these 3 to 4 hours of copying and pasting, I would need to go back through and cross-check to make sure that I didn't mess anything up. So you can see that this process is really taking a lot of time. And I know for those of you who worked in Publisher alone, this process alone would make you looking for other options. So after doing this process a couple of times, I started looking for other solutions on how to make this process easier. And I discovered Quarto. So integrating Quarto automated reporting into this pipeline cut my process down from 3 to 4 hours of copying and pasting to 30 minutes of running the script. So I would call that a win. Again, no more copying and pasting. I was automatically pulling in my tables and formatting them in Quarto. And then I was able to also integrate some cross-checking steps so I wouldn't have to manually go through each table and make sure each value was correct. So again, from 3 to 4 hours down to 30 minutes, this was a huge improvement for me. So what is Quarto? So Quarto is a tool that lets you input both text and code, and it helps you format your text, and then it'll also execute your code. So that could be computations or creating visualizations. And it will give you a variety of different outputs. You could output documents or slides, websites or dashboards. One example is if you had some content and you wanted to export it into slides, you could also in one line of code then create a report using that same content. So you can see that it's a really quite a versatile tool. So let's take a look. We're going to do just a really quick demo of what a Quarto document looks like, because my goal is for you to not be scared by any of this at the end of this presentation. So in RStudio, when you start a new Quarto document, it'll look something like this. And you will basically have two different parts here. So if we start first with the text part, this is where you're going to enter all of your content. And Quarto formats using Markdown. So you can see these asterisks and these pound signs are all part of that Markdown formatting. Now, this can feel really intimidating to start. And so RStudio and Quarto, they made it really easy for you. There's this little toggle at the top you can see that says visual. And it lets you toggle into the visual mode. So you can see all of that Markdown formatting live. So you can see that those pound signs turn into headers, that render text that was covered in asterisks is now bolded. And this makes it really easy to format your text without knowing Markdown. So Markdown should not be a barrier for you here. And you can kind of toggle back and forth between visual and source mode. Okay, so now that we have our content, let's move on to our code piece. So there are 4 code chunks right here in this kind of demo report. And you can see everything from basic addition and multiplication, so basic computations, into bringing in some more complicated R functions, like summary tables, and then like plotting the pressure data down here. And additionally, there's also this header at the top, which is called the YAML header. And this is what is telling R and Quarto what sort of output you want. So right here, I specify that I want a Word document. So I'm going to go ahead and we are going to do a little demo of what rendering these different documents might look like. So this is that same demo report, but instead of a Word document, I'm going to output an HTML document just to kind of show you what that looks like. You can see RStudio thinking here, rendering my document. You can see that it combined all of the text and formatted text. There's my summary table as well as my pressure plot into an HTML document. But reporting in HTML is not really useful. So let's go ahead and report it or export it as a Word document, something we could send to our colleagues so they could also edit it. So you can see here, my Word document is exported. Apologies for my Microsoft permissions issues. You can see all of the same data and content here. So we've got our pressure plot, we've got our summary table, and our formatted text. But that document looks pretty boring. So what if we wanted to include something that had our own headers? Like here, I've got the prescription drug monitoring header, and maybe I also want to have this footer, so all my reports look the same. So this is a template document that I made. And if I wanted to use a template document to make my report, I could go ahead and just specify that in the YAML header here and tell Quarto that I want to use a reference document, and the reference document that I want to use is that template document. That's the document I just opened. So let's go ahead and re-render this demo report, and hopefully we'll have the right header and footer and start to look more consistent to our other reporting. We're going to go down here to our files. We're going to open up that demo report that was just rendered, and you can see all of our content is here, but now with the header and footer that we specified in the template document. So this is starting to look like a real report. And you can see, I know by this point that you're highly convinced that you want to convert your reporting to R. So how and where do you start? So here's a picture of the actual report that I put out quarterly for the prescription drug monitoring program. I think a good place to start is a template document, just so all your reports look the same. So go ahead and make a document that has the headers and the fonts that you want, and just export your content from Quarto using that header and footer. Now, if the pain point is not really adding a header and footer, but instead is copying and pasting tables, like this one, this is my least favorite table in this report, because copying and pasting it meant not only that I had to copy these values, but also the ones inside the brackets, and this took a really, really long time. So this was the first table that I wanted to generate using automated reporting, and I could do it in a couple lines of code. So here, I read in my data. This is my raw data. Don't worry that I named it table 3 when actually it's table 1. So you want to read in your data, and then I clean up my row labels. So these row labels are just these labels here. I'm cleaning up my column labels, these columns here, and then I put in this big chunk of code, which looks really scary, but is mostly due to the fact that all of our tables are this beautiful minty green, and I wanted to replicate it as much as possible. So I'm adding my fonts, I'm adding my beautiful minty green background, I'm adding my headers and borders. I'm adding my table 1 label, as well as my reference here. So this little reference script is being added using flex table. So using this package, I can generate kind of all of my tables in my report. And again, this goes back to saving me a lot of time, consistently copying in all of my raw values, and then reducing the amount of errors. If it's in my raw data, I now am sure that it's going to be in my table. You can see in just this little bit of code, the time savings here. But let's say that generating tables isn't your biggest headache, and instead you want to automate some text. So for me, my next biggest headache in this reporting was changing all of the dates. So I'd have to go through and update all of this second quarter, if it was the third quarter, and then I could never remember what the dates were of each quarter. So to not do that, I told Quarto what quarterly report I wanted to run for what year. And then I wrote a little bit of script. So you can see here, this is what the title looks like when it's parameterized. I wrote a little bit of script so I could automatically update all of these dates, again, saving me time, adding consistency, so I'm not forgetting to update any of these date fields, and reducing errors. And then the last thing, I also almost always report on the same percentages. So instead of copying and pasting these percentages over and hunting through the tables for all of these values, I went ahead and just created variables with the values that I'm interested in. So these values will all automatically update in my table. And recently I got very snazzy, and based on what these percentage values are, I added in this green text, whether it was slightly increased, or decreased. So I don't have to even change any of those, any of that wording as well. And one big key advantage of doing all of this is that I can spend a lot more time reading my report, checking to make sure the values are correct, and then writing key takeaways versus spending a lot of that time copying and pasting. So I kind of get to the meat of the report quicker. So to wrap up, I just want to do a couple tips for beginners. If you're thinking about doing Quarto, I think my biggest advice is to start small and start with one thing at a time. Maybe it's just making sure that all your headers and footers are the same. Maybe you're automating some dates. But as you can see from this current process, I did not revamp my whole data pipeline. I'm still using SAS code to create my raw data, and I'm only using Quarto here to save my time. Leverage the Quarto cheat sheet. So Posit puts out these lovely little cheat sheets that kind of help you with some functions and getting started. The Quarto cheat sheet is really great. I reference it frequently to kind of figure out some of the more quirky things with Quarto. Create a practice report. I think the best way to learn Quarto is to try and practice and create in Quarto. And then my last tip is to ask for help. Our community is super welcoming. Everybody is so helpful and interested in helping you learn how to code. So reach out. I think more often than not, people will get back to you and be able to help. And that is all I have for today. Thank you.
This was great. Thank you. Appreciate you presenting for us. We do have, just from the chat, did we mention Quarto and R are free licenses? They are free. It's a super nice, easier sell to your IT department. Let's see, one question. Have you had any issues with getting blocked by Carbon Black, the EDR security software installed on our state computers, when trying to render your Quarto docs? I have issues with this anytime I try to render Quarto docs from my work computer. No issue with rendering R Markdown files, though, which, yeah, R Markdown doing a lot of the same things, or kind of, I don't know, the overlap is high. So, yeah.
Yeah, this was in R Markdown until this last month. I wanted to update it for Quarto for this talk, kind of get with the new program. But I haven't had any issues with rendering HTML documents or Word documents. Dang.
Yeah, it might be just that particular agency, maybe.
That's unfortunate.
Any other quick questions? Probably have time for one more quick one if people have. Have you seen benefits switching from R Markdown to Quarto? A question that I also have, because yeah, I've done some stuff in R Markdown but never touched Quarto.
No, I haven't, to be honest. I noticed that a lot of the resources, so I made this report about a year and a half ago, and it was all R Markdown. So I started in R Markdown, and there's been a lot of talk about Quarto. I decided I wanted to kind of dip my toe in, but like there was no additional functionality add for me. I know it's kind of the new exciting thing, so I wanted to use it, but like I don't use Python. I don't use a multi-language input into this, so I'm using R. I think all of this could be achieved with R Markdown and was achieved with R Markdown before Quarto. So if you only know R Markdown and you feel really comfortable there, I would say stay living in that world. I didn't have any added benefit from Quarto for this.
Great. Well, I think, yeah, we're in our last quarter here. So I think thank you once again for presenting. We can move on to our last presenter here. We have Will Baker Robinson from the VA here to talk about some data linkages, I think, between agencies maybe. So yeah, take it away. Thanks.
All right. Hopefully y'all can see my screen. Hi, everyone. I'm Will Baker Robinson. I'm at the Portland VA and the OHSU PSU School of Public Health. We are contracted on a project with the OHA IVPP team. So today I'll be presenting on a data linkage we did as part of that project, and all of this work was done within R. Okay. Switching slides. So a little background. AVERT is Advancing Violence Epidemiology in Real Time. It's a CDC-funded IVPP project. We're performing syndromic surveillance of violent injuries such as firearm injury, intimate partner violence, and then child abuse and neglect, sexual violence, and some other ones, as well as mental health conditions, which were just kind of tacked on. And the data source for this is going to be Essence. So that's the state syndromic surveillance data source, which gets emergency department visits within about 24 hours. So it's pretty real time. This work that I'm presenting today is from a supplemental linkage project, which gave us 1 year of funding to perform linkage with Essence data. There are several linkages involved, a de-identified and identified linkage. And today I'm going to be focusing more on that identified linkage between our between the emergency department and hospital admission discharge data and the organ violent death reporting system data. So this graphic here gives kind of an overview of the different linkages that were done as part of this supplement. And today we're focusing on this orange box here. So within any data linkage, you're going to have a couple of key steps. Probably the most important and the most time consuming is related to the data governance. So setting up those data use agreements, figuring out how you're going to securely store and access data, getting the proper approvals, IRB. We had to go through a Science and Ethics Council review to determine whether or not it was public health practice or research, et cetera. So I don't have a slide on this, but this is one of the most important steps and the most time-consuming steps when you're performing linkage. The next step will be the data exploration and cleaning. So for each data set you're going to link, you go through your data and see what variables you have for linkage, and then harmonize them for the linkage. Then you're going to link the data and finally check your linkage model and perform analysis. But here we're just focused on linkage. So for the data exploration and cleaning, besides those data use agreements, this is going to be one of those most time-consuming steps. So you really need to get to know your data and understand what values you would expect, maybe what the erroneous values are that are showing up. So you really need to perform a detailed exploratory data analysis. So looking at missingness, looking at distributions of values. Maybe you're seeing like a certain date of birth, like a common one would be January 1st is showing up more frequently than other dates of birth as like a default. So you may set that to missing. You'll need to then look at the values. So like maybe sex in one data set is coded as male and female, and the other data set is M and F. So you'd need to set those values so that they're the same across those data sets. And then finally, you would select your unique ID that identifies each of the participants or patients in your data sets, and then your desired linkage variables. One area that I'm going to go into a little more depth here is cleaning of names. This was really important to this linkage that we did. And we brought in a US Census data set and a Social Security data set, and used the tidyverse package stringer to modify the names that we had in our data sets and join in these auxiliary data sources to understand how potentially names were being, I don't know, how they're potentially messy or erroneously coded. So looking for things like suffixes or dangling initials, things like that. And we broadly followed some cleaning steps from the US Census. So like I was saying, we're using regex statements and the stringer library to do that. And here's an example of all the different cleaning steps that we performed on the names. So making names lowercase, so that'd be a function like string to lower, replacing none or null or empty string to end a character, removing suffixes, so you could use string underscore remove for that, and then a regex statement to find these different suffixes, looking for the dangling initials, or a single dangling initial. This one's a little more challenging because you have to account for names like O'Neill. You wouldn't want to cut off the O if there's no punctuation there. And then finally, removing spaces and punctuation and digits that may occur. So just like generally, we're using just like pretty standard tidyverse code here. I really like the Nanier package for exploring missingness. It has some really great functions for that. So you can see how variables are missing together, or get an overall sense of missingness in your data set. I find the Janner package is great for cleaning and just quickly viewing some frequency tables with the table function. ggplot is great for making different plots of the distributions of your variables. And then finally, like I was mentioning, with the name data, you can join in other tables. So like, for example, you could join in a table of expected or valid zip codes to your data and find zip codes that you might not expect. You could also use something like a string function and look for zip codes that have non-digit characters with regex, or zip codes that are shorter than 5 digits, things like that. So there's plenty of different ways to look at or try and find those erroneous values, and R has some really useful functions for that. And then for the data cleaning, really a lot of if, else, and case when statements. And then, like I mentioned, the stringer package is super helpful for this. And LibreDate is pretty essential for working with dates as well. And those are both from Tidyverse. Getting into the data linkage itself, there's three main probabilistic data linkage packages in R. There's FastLink, there's record linkage, and there's also Reclin. We chose to use FastLink. It gives some really nice string distance comparison measures. You can set partial match thresholds, and you can also perform blocking, where you would say, based on a certain variable, two pairs need to match on a certain variable to be a match. So you need to have the same hospital for a pair to be considered a match. So it decreases the number of potential matches that you have to consider and makes it more efficient to run. I know we're a little short on time, so trying to go quick here. These were the variables and the comparisons that we used to perform this match. So these are string comparisons for those first three variables. And then the cutoffs that we used. Zip code, we did a numeric comparison. Zip codes are hard to give partial matches for. Anyway, we could go more into that separately if you want. And then sex, we just did an exact match. Here's an example of running some FastLink code using the FastLink wrapper function. The actual code that we used was a lot more complex. I'm happy to share that. The FastLink wrapper function doesn't give you quite as much flexibility. So you have to use the same type of string comparison for each of your string distance variables. And there's another method you can use that's kind of a workaround. So that allowed us to do Jar-Winkler distance for name and then a Levenstein distance for date of birth. And then when you're checking your model, you're going to want to create a histogram of your match weights. You would expect to see a bimodal distribution. If your model is performing well, that would indicate that it's properly discriminating between true and false matches. You'd then want to select a sample of 100 to 1,000 match pairs, kind of depending on how many match pairs you have and how much time you have, and manually review that to get a sense of the posterior probabilities and how well that model is working. So the higher your probability, the more likely you'd expect for those match fields to have matched across for each of those. So if you have a probability of 0.90, you would have expected all or most of those fields to have matched for that pair of records. It's also important to decide if, or kind of try and understand if the number of matches are what you'd expect, and if they're not, what might be going on. If you have issues with data cleaning, or there are other maybe unanticipated sources of error within your data sets. You can also consider a subset of matches that you might expect to match. So in this case, that would be looking at the records that had a discharge disposition of fatality and trying to understand why those didn't match between the two data sets. And then finally, you'll need to decide on that posterior probability for what you determine a match. Kind of getting down towards the end here. This is just some brief results from our linkage. We found that our model performed really well. So that was cool. Yeah, I guess I can cut it off here and we can get to questions. Sorry, that was so quick. Yeah.
Yeah, that was very interesting. Thank you. We've got a lot of discussion in here on good functions and packages that people are finding useful, which is great. Not seeing any specific questions for this one, but if anybody has one, you can pop it in really quick. Is there a way to do phonetic-based name matching rather? That's really interesting. I've not thought of that.
Yeah, you can do phonetic name matching, and that's historically been done more with like SoundX and some of those other string distance or string comparison methods. I believe that's an option in FastLink. It's definitely an option in some of the other linkage work that I've done in the past. Jaro Winkler though is really good for accounting for some of those minor differences that you might see in names, different spellings and things like that. So I'm a big fan of that comparison.
Nice. All right. Well, I think we are pretty much at time. So thank you again for presenting. I'm gonna just take the opportunity to share one more time that SORA is looking for general members for our executive committee. It's just a monthly 1-hour meeting. Our next one is this upcoming Tuesday. We use those meetings to just plan these events, have some development opportunities. You can join in those discussions and vote, and we'll be having our elections for named positions in January. So this is a good way to get involved without too big of a commitment, ahead of time, just so you can see if that's something you might be interested in. So if you are, shoot me an email, michael.mativa@dor.oregon.gov. But yeah, thank you all for coming. Appreciate the engagement and attendance, and we'll hope to see you at our next event.